Hi, lovely one. My name is Anthony Osei-Mensah, popularly referred to as Sir Tony, the mathematics doctor. In this video, I am going to teach you something about the sector of a circle. That is to say, the minor sector and the major sector. The formula for finding the area of a minor sector and the formula for finding the area of a major sector. And also, I'm going to solve some questions for you to understand how it is done. So let us now get into the video. By two radii and an arc. So if you study this diagram, there are two radii with an arc down here or up there forming a sector. Now a sector formed from two radii and a minor arc is referred to as a minor sector. So the minor sector is what we call two radii with a minor arc. So that one is smaller than half of the circle. So a sector which is less than half of the circle is called a minor sector. And a sector which is bounded by a major arc and two radii, or two radii and a major arc, is what we call a major sector. And that sector which is bigger than half of the circle is referred to as a major sector. So a sector, whether minor or major, forms an angle at the center of the circle. So it always gets an angle that we describe as theta at the center of the circle. And the angle of the minor sector is between 0 and 180 degrees. So 0 degrees and 180 degrees. Between this, we have something called the angle of the minor sector, or the minor angle. Then above 180 and 360 degrees, that is between 180 and 360 degrees, is what we call the major angle for the sector, or the major sector's angle. So get to know how the measurements are. If the angle is between 0 and 180, it is for the minor sector. And the angle is between 180 and 360 degrees, it is for the major sector. Also, the angle of the major sector is always gotten when you have the minor sector. So it means whoever has the angle for the minor sector can get the angle of the major sector, and vice versa. If you have the angle for the major sector too, you can get the angle for the minor sector. Just subtract the minor sector's angle from 360 degrees and you get the major angle sector. So the major angle sector is always giving us 360 degrees minus theta. So we realize that the rest of them will become that of the major, because if theta is for the minor, then 360 minus theta becomes that of the major angles, or the major sector's angle. So that is how we can find an angle for the major sector when the minor sector angle is found. So please get to know how to do that. Now, the diagram shows clearly the major sector and the minor sector. So if you did see this one, this is the minor sector and this is the major sector. So you realize that in the top diagram, the shaded portion is what we call the major sector, and the one that has not been shaded is the minor sector. So please take note of that. Take a look at the formula for finding area of a sector. As we saw from the beginning, a sector is any part of the circle which is bounded by two radii and an arc. So if the arc is minor, it becomes a minor sector, and if the arc is major, it becomes a major sector. So with a sector, if you draw a sector and then you have the two radii and then you have the arc, you realize that there is an angle at the center which becomes a minor angle again. So this minor angle shows you how large the sector is. So if the minor angle lies between 0 and 180 degrees, it makes a sector a minor sector. So if you want to find the area of this minor sector, you need to consider the fact that the sector is a part of the circle. So the part is the theta out of the 360. That fraction of the theta times the circle, which is pi r squared. So the area of the circle will multiply that fraction to give you the area of the sector. So area of a sector is equal to theta over 360 times pi r squared. Because this theta is a minor sector's angle, or the minor angle, then this formula becomes the area to find the minor sector. So area of a minor sector, area of minor sector is giving us the angle at the center, which is theta, divided by 360 degrees times pi r squared. That is times the area of a circle. So theta over 360 times pi r squared is what we call area of a minor sector. Now let us look at the formula for finding the area of a major sector. But before that, know that theta is the minor angle lying between 0 and 180 degrees. Let us take the major sector's formula. At this point, we want to take a look at the formula for finding the area of a major sector. If you found the minor sector and you use theta over 360 times pi r squared, Then the major sector will use the major angle, and the major angle has already been shown when we're doing the length of a major arc. You realize that we're going to subtract the minor angle from 360 degrees. So the major angle will be 360 minus the minor angle, which is theta. The minor angle lies between 0 degrees and 180 degrees. So if you have an angle lesser than 180 degrees, that means it's a minor angle. And if you're using that to calculate for the major area of the arc, that means that you have to subtract it from 360. So the formula will give you 360 minus theta all over 360 times the area of the circle, which is pi r squared. So this is the formula for finding area of a major sector. The major sector has the major angle and has two radii with the major arc. So theta over 360 will not be the best formula to use. But 360 minus theta over 360 times pi r squared, because this is a major sector. And a sector is part of the circle. That is why we have multiplied pi r squared, which is the area of the circle, to this. The part is the 360 minus theta over 360. That fraction is a part of the whole times the area of the circle forms the area of the major sector. So this is the formula for finding the area of a major sector. Next question reads, find the area of a sector OMN, given that angle MON is 70 degrees and the radius of the circle is 8 centimeters. Now this is the diagram given to you. The angle at the center, which is theta, is 70 degrees. The radius is 8 centimeters. And pi has been given as 22 over 7. Let's get into the solution. To solve this question, we need to get what they want from us. We have been asked to find the area of the sector. Now this is the sector in the diagram, the sector OMN. And this sector is a minor sector, so we are finding area of a minor sector. So if we are getting the area of a minor sector, then the formula is theta over 360 times pi r squared. The minor angle theta has been given as 70 degrees. Our r has been given as 8 centimeters for radius. And then pi has been given as 22 over 7. Let's do the substitution. So theta has been given as 70 degrees. So 70 over 360 times our pi is 22 over 7 times the radius is 8. So 8 squared. Let's simplify this. So it will become 70 out of 360. Let's simplify it. So on the calculator, 70 divided by 360 will be 7 over 36. That means the zeros will cancel out, remaining with 7 over 36 times 22 over 7 times 8 squared is giving us 64. Now let's multiply all together so that we can move to the final answer. 7 divided by 36 on the calculator times 22 divided by 7 on the calculator times 64 is supposed to give us 39.11. So therefore the area of the sector or the minor sector OMN is equal to 39.11 centimeters squared. Since it is an area, the unit will be in centimeters squared, and the unit for the radius was centimeters, 8 centimeters. So since the unit is centimeters, it will be 39.11 centimeters squared. So finally, the area of the sector OMN is 39.11 centimeters squared. Thank you. Next question reads, the area of the circle below is 48 centimeters squared. Find the area of the shaded sector AOB. Now this is the diagram and this is the shaded sector AOB. Now let's get into the solution. Now if you check from here, for us to solve this question, we need to put down the parameters. So solution. Now the area of the circle below is 48 centimeters squared. So area of circle is equal to 48 centimeters squared. Once you see this, you realize that two things can come into your mind. Using the area to find the radius, or just keeping the area to use it to find the area of the shaded sector. So now we know that area of circle is 48 centimeters squared. So let us keep it for now. Now we know that a sector is this particular one here, and that sector is the minor sector. So if the shaded sector is a minor sector, then the area of the sector area of shaded sector, which is OAB, will become theta over 360 degrees times pi r squared. Now, if you should analyze this formula, you realize that theta has been given and then it is 120 degrees from the diagram. But pi is not there and the radius is not there. Even though we know pi, we don't know the radius. Pi is a constant, so we can even get it ourselves. But what about the radius? We don't have the radius. So there are two things involved. Go and get the radius from this particular 48 as the area of the circle, or this pi r squared here represents area of a circle. So we can boldly say pi r squared is still 48 centimeters squared because the area of a circle is pi r squared and the area of a circle has been given as 48 centimeters squared. So therefore pi r squared is 48 centimeters squared. So in this formula, wherever you see pi r squared, just replace it with 48 centimeters squared. You will have to replace pi r squared with 48 centimeters squared. Let us get into that solution. Now, theta is 120 degrees, so we do that. So it will be 120 degrees divided by 360 degrees times 48, because pi r squared is 48. So then we just have to simplify this and we get the area of the shaded sector AOB. So after simplifying, we get 1 over 3 times 48. So 1 over 3 times 48 on the calculator should give us 16. It means 3 here, 1, 3 into 48, 16. So we get 1 times 16, which is 16. So at the end of the day, we get 16 centimeters squared. So therefore, the area of the shaded sector OAB is 16 centimeters squared. So go through this very well. This is a little bit tricky because the radius was not given, but fortunately the area of the circle was given as 48, and this formula for area of the sector is having the area of the circle multiplying theta over 360. So you just multiply it by 48. That is the meaning. So pi r squared is represented by 48. That is the meaning, because pi r squared is the area of the circle and the area of the circle is 48. So it means that a substitution has to be done. So the answer for this question is 16 centimeters squared. Thank you very much.